Today, with the help of an activity, we will arrive at the formula for the surface area of a sphere. The surface area of an object is the sum of all the areas of all the shapes that cover the surface of the object. Let's get back to some more basics. This is a cylinder. Its curved surface is also called the lateral surface. The curved surface area of the cylinder is equal to the product of the circumference of its base and height. What we have with us is a sphere cut into two. Let's measure the radius of one of the hemispheres. The radius of the sphere and the hemisphere is 14 centimeters. The biggest circle that we get when we cut a sphere into two halves is called the great circle. Its diameter is 28 centimeters. Now this is a cylinder with its base congruent to the great circle of the sphere. The radius of the cylinder is also 14 centimeters and its diameter is 28 centimeters. Now let's measure the height of the cylinder. It is 2r or 28 centimeters. The height is equal to 2 into the radius. So what we are going to prove today is that the surface area of a sphere is equal to the curved surface area of a cylinder. Let's first take the hemisphere. Now, wind a rope closely around the curved surface of the hemisphere from the top to the base completely. Once the rope has been wound over the hemisphere completely, this is how it looks. Now, let's make a mark on the rope at the point at which the rope completely covers the hemisphere. Now, let's cut out the extra length. Now, let's unwind the rope. Once the unwinding is done, let's place the hemisphere aside and measure the length of the rope with a meter scale. It measures 18 meters. Now, let's take the cylindrical can which circumscribes the sphere. In the same way, let's wind another rope closely around the curved surface of the cylindrical can from the top to the bottom. Take care to cover the entire surface without leaving any gaps. Make sure that there are no overlaps either. Mark the rope at the point where it covers the cylinder completely. Now, I shall cut the rope at this point. Now, let's unwind it and measure the length of the rope as we did earlier. Now that we've unwound the rope, let's keep the cylinder aside and measure the length of the rope. It measures 36 meters. Since the thickness of the rope used in winding the hemisphere and the cylinder is uniform, we can say that the surface area is proportional to the length of the ropes approximately. Now, let's compare the lengths of the two pieces of the ropes used. We see that the length of the rope used to cover the curved surface of the cylinder is twice the length used to cover the surface of the hemisphere. Surface area of cylinder is equal to twice the surface area of a hemisphere. Archimedes, the great mathematician, found out that the surface area of a sphere is the same as the curved surface area of a cylinder, provided that they have the same diameter and that the height of the cylinder is the same as its diameter. Therefore, the surface area of a sphere is equal to 4 pi r square.